For the mid-Taiari, we expect the climate to become drier and droughts to become longer and generally the place to dry out. That will be punctuated by shorter, more intense rainfall events, which will probably lead to more severe flooding. This place is already quite dry, and so the demand on our freshwater resources is already quite high, but that's only going to increase as we transition into that drier climate. The Taiari River is the fourth longest river in New Zealand, and it's really significant for fish because it doesn't have any barriers along it until you get about 220 kilometres upstream. So if you're thinking from a fish perspective, or a migratory fish in particular, it's one of the biggest catchments in the country because these fish can travel 220 kilometres before they hit a significant barrier to their migration. Some of those migratory fish include longfin and shortfin tuna, giant cockapoo and other important species that are inhabiting some waterways around here in Hindon. They don't go much further upstream than here. And lamprey, kanakana, the adult kanakana are actually coming up the river, and like the giant cockapoo, they seem to peter off about here. So we know some of these catchments around us, around the mid-Taiari part of the river, are really important to kanakana. There's many species of non-migratory galaxids that live in this catchment. Oh, got one. Here's a little Eldon's galaxis. Fat one. It's probably a female with eggs ready to spawn. Here's an Eldon's galaxis that we've just caught, and they live in this waterway, probably because there's a barrier or something downstream that's stopping the trout from coming up any further. This fish is threatened with extinction. The majority of the species lives in this one catchment, which is pretty cool, and that's also the same with most of the other species of galaxis that live around here, like the central otago roundhead and the Taiari flathead galaxis. They're pretty much almost exclusively found in the Taiari catchment. It's not hard to imagine what drier periods might mean for freshwater fish like this. The predicted changes in climate mean that these waterways might dry up. Another thing that might happen is flood events will become more intense, and that can cause massive erosion events through small tributaries like this. So we might see the fish getting flushed out, huge sediment inputs from erosion coming down and smothering their habitat. These fish rely on barriers stopping trout from coming up and predating on them. So with changes in hydrology and more intense floods and stuff, we might see those barriers disappear, and then trout will be able to push up further into these tributaries. That would mean a localised extinction for this population if that did occur. So there's a few things that we can do. One important thing is protecting those seepages and wetland systems at the top of these tributaries. They're going to act like a sponge and soak up that water during the low periods. They'll mitigate any of the effects of the floods by reducing the flood flows, but they'll also provide water during those dry periods. The other thing we can be doing is planting out these steep-sided hills, preferably with native vegetation that provide a lot of food and habitat for native insects, which in turn provide food for the fish that live in these waterways. And those plants, they'll also help stabilise the banks so that when there is high flow and big floods coming through, those banks will be less likely to erode away. Southern Salt Lake is a really significant place because it's New Zealand's only salt lake. It's this body of water that's sitting on this bedrock and it doesn't lose any water, so the only water it loses is through evaporation. Southern Salt Lake fills up with water typically through the winter, but of course whenever it rains. But during summer, there's very low rainfall, it's really hot and dry, and all of that water evaporates. And it's that evaporation process which concentrates those salts and gives us the really salty environment we have today.
The salt levels mean that there are quite unusual organisms that make their home in this lake. We have some very interesting invertebrates. We have the tadpole shrimp, which is very, very interesting looking enigmatic creature, looks quite prehistoric. And then there's also the clam shrimp, which is nationally endangered. Because they're adapted to this environment, their eggs will actually be very tolerant to drying out. So they could dry out for a year or even probably multiple years and just wait for the rains to come again when they will hatch out. And these shrimps will live in the water for a short period of time, and then when they get stressed and they notice the water level going down, the temperature going up, they'll lay some more eggs, and that their life cycle will carry on like that. This is a very special habitat, a special environment that is obviously very sensitive to the climate, because this balance between rainfall and evaporation is what this is all about. So any changes in the rainfall pattern or in the temperature and winds that drive evaporation will tend to drive this system into being either full of water more of the time, or dry it out more of the time. And eventually, if the climate changed enough, this basin could fill up, and then it could spill out, it could have an outflow, and it could flush all the salts out, and it would just become like any other kind of small lake.
Things that we can do to adapt and become more resilient to the changing climate up here in the Mid-Taiari is to plant some trees that are fire-resistant species, so things that aren't going to increase the fire risk in this environment. So that will allow us to keep a lot of our native plants in situ, our tussics, which are really important for that water capture and the hydrology. We can also look at restoring those small feeder wetland systems, which will be fundamental to capturing water during wet periods and providing water during drier periods. We need to manage the minimum flow in this river to ensure that we have enough water in these rivers, and that will help plan and strategize how we use water most efficiently as it changes and becomes drier. Some other things we can consider are becoming less dependent on irrigation needs, for instance, and changing land use patterns to adapt to that dry climate.